In the last episode, we made a retrofit service to fetch data from the weather API. We also used Gson to convert this data from JSON to Kotlin objects. We could technically only use this retrofit service and create a nice user interface to display all of the data we are currently getting. Doing this wouldn't be really performant and efficient though. What if the user doesn't have an internet connection? Or do we even really need to fetch data from the server every time the app is launched? Shouldn't we cache all of this data? The answer is yes! In this tutorial you are going to learn how to create a local SQLite database using the Room library. And by the end of this tutorial you will understand terms like entity and data access objects, otherwise known as DAOs. Hello, welcome to ResoCoder, and before we get started with implementing our database, let's do a quick fix of current weather entry which we have added in the previous part. This is because if I launch the app which we have created from the previous tutorial, forecast MVVM has stopped. And why is that? Well, when we go over to the logcat here, and we take a look at our error output, so somewhere over here, number format exception, expected an integer but was 10.5, which is a double at line 1 column something, and its current wind MPH. So let's see in our current weather entry what type is the wind in miles per hour. And for sure it is an integer, and we need to fix this to be a double, because when we were creating in the last part this class through the Kotlin plugin, right, because we have created it with Kotlin data class from JSON plugin, and this plugin saw that in the JSON we pasted over here there was just an integer, and there for some reason there wasn't a decimal place. But now when we get data which has decimal place for wind and also for other values, we are getting a type error because floating point number is not an integer. So let's fix this. This will be double, and also wind kilometers per hour will be double. You see, temperature Fahrenheit is double, but temperature Celsius is an integer. Pressure in millibars should definitely also be a double, just like pressure in inches or something. And it feels like Celsius will also be a double. Let's also change the precipitation to be double, so millimeters and also inches, and probably also visibility kilometers and also miles, and now we should be good to go. Now let's also go over to the build Gradle for the whole project, and we are going to upgrade our Kotlin version because now there is a stable 1.3.0 Kotlin version, so we can remove this RC from here. And if you have started working through this tutorial later than I have started, the probability is that you won't need to do this change, and you can even have some Kotlin version 1.5.0, what do I know? But 1.3.0 stable has even stable coroutine support, so that is pretty cool. And while we are at it, let's also upgrade all the plugins, so build tools and also navigation, save arcs. And yeah, so hit sync now. And now let's take a look if our app still runs properly. So let's launch it in an emulator, and then we will actually get to creating the database classes and all of that. And yeah, now the app is launched and we don't get any errors, so everything is working properly. So now let's close everything off, and what we want to do now is to move a bunch of classes, more precisely current weather entry, condition and also location, over to a new package which will reside in data, but we also want to create a new sub package. Its name will be db for database. So and in this database we want to have these three classes, so condition, current weather entry, and also location, and let's drag them over to db and hit refactor. And under db package we want to have two different packages. One's name will be entity, because we are going to be creating entities in just a little bit, and the another package will have name unit localized. We are also going to get to this package in just a little while. And now let's move the condition and current weather entry and also location to the entity package. So refactor again. And to have all of this nicely separated, now we have the base package, which is data. Then we have DB for database stuff. And we don't want to have directly response over here because response belongs under the network package. So let's create a new package, network, and let's move the response package under the network package. We only want to move package, not move everything, and hit OK. So refactor. Now we are good to go. Alright, now let's come back to data, DB, and entity, and let's edit the current weather entry, which we have actually edited at the beginning of this tutorial because we needed to fix a bunch of things regarding the types of our fields here. Now we want to make an entity out of this class, but before we do that, let's actually delete some of the properties which are residing in this class. That's because we aren't gonna be needing them. And if we delete something which is not needed, when the JSON is being parsed by the Gson library, and Gson library doesn't see that this class has last updated epoch because we deleted, right, like this. Gson doesn't throw any error, it just ignores this property which is deleted and it doesn't care. So we can safely delete even last updated because we aren't gonna need it in this tutorial series. We only need the temperatures, is day, we also need the condition and also wind MPH and KPH. We aren't gonna need wind in the degrees, but we are only going to need the wind direction. Then we also aren't gonna be working with pressure, so we can delete even these two properties. And also we aren't gonna need humidity and also clouds, so let's delete them too. And that's about it. So these are all of the fields that we are actually gonna be using in this tutorial series, and all of the other fields which we have just deleted can be safely ignored. Now we want to make an entity out of this class, and entities are basically tables in the SQLite database. So we want to annotate this class with an entity annotation, which is from Android X Room library. And we also want to set the table name for this entity. And the name of the table for current weather entry will be current weather. And the table with the name current weather will have columns which will contain temp C, temp F, is day, condition, and all of those other properties. They are going to be columns in our database table, which is called current weather. But we have one problem. Room database, and actually SQLite database, because Room is just a wrapper on top of the SQLite database, and SQLite can only store primitive data types. So for example, double and integers and also strings. It can store that, but it cannot store condition, for example, because condition is a custom class and it contains text, icon, and code. So we need to be able to fit objects of type condition inside our table in the SQLite database. And to do this, we need to annotate this condition with an attribute embedded, which is also from Android X Room. And we also want to prefix this, these fields with condition and underscore. So in our database, the condition object will not really be an object, but it will be in 3 separate fields, and their names will be condition underscore and text, and then also condition underscore icon and condition underscore code. So we are actually going to somehow unroll our condition objects into just 3 simple fields, which can be stored because those fields in conditions class are only primitive types. Because this current weather entry class is now an entity, we need to add one property to this class, and that is a primary key. A primary key can be set to be any property, but we are going to create a special property for our primary key, and its name will be ID. So let's create var ID. It will be of type integer, and we will set it to be a primary key. So let's also just simply annotate this property, and we are going to set auto generate to be false. Primary keys are used to identify all of the different entities which are in our table. But in our case, there can be only one instance of current weather entry in our database, because it doesn't make sense to have two current weather entries, because hey, there is only one current weather, not two current weathers, right? This means that we can actually assign a constant primary key, so a constant ID, to our entity class current weather entry, because there can be only one of them, and for that reason we always know which we want to get. We only want to get the one that is present in the database. There is no other current weather entry, only one instance of it is present in the database at any given time. So now let's create a constant for the ID. So const val current weather ID, and it's going to be equal to 0. And whenever we want to get the current weather from the database, we know that we can find it with this ID, which is 0. And now let's assign this ID to be current weather ID. And this is also the reason why we set auto generate to be false for our primary key, because we don't want the room library to generate it for us because it's constant, so generating it would be actually counterproductive. Alright, now let's take a closer look at the current weather entry class. We can see that there is temperature in Celsius and also in Fahrenheit. There is also miles per hour and kilometers per hour, millimeters and also inches. But the thing is that the user using our app doesn't want to see the values in millimeters and also inches at the same time. We will let the user decide which values he wants to see, so imperial or metric, and then we will display only those values. So it's actually kind of wasting of the resources, because we need to somehow retrieve all of this data and store it in a memory, and also if we are using some list view, the recycler view will have more data to deal with and all of that. And also classes which have data which is not currently needed are just harder to work with. For that reason, we are going to create a separate set of classes which will be imperial and metric current weather entries. We will use those classes to retrieve only the proper fields, so for example only Celsius or only Fahrenheit, whenever we are actually retrieving from the database. We will want to have an imperial and also the metric current weather entry under the unit localized package. Even though they are imperial and metric, they share a lot of common things. Because of this, we are first going to create an interface unit specific current weather entry, and then the metric and imperial current weather entries will only implement this interface. So let's create a new Kotlin interface under the package unit localized, and this one's name will be unit specific current weather entry. And I'm going to cheat a bit and paste the code in here, because I think that it's quite boring to see me just create a bunch of properties. And remember that you can get the code from the link in the video description, which is going to take you to resocoder.com. So you can just freely paste it from there and you will be good to go. Alright, so here we have it. We will have only temperature, condition text and icon URL, wind speed, wind direction, precipitation volume, fields like temperature and also visibility distance. You can probably also notice that the field or property names are more clear and nice in this unit specific current weather entry, and that's because we are going to use some annotations in the actual classes and not this interface. So we will actually get the field call or property called temp C, but we can call it nicely like temperature in the code which we'll be using throughout the app. Alright, now under unit localized, let's create another class, and its name will be imperial current weather entry. Alright, let's delete these curly braces, and we are going to make it inherit from unit specific current weather entry, or actually implement, not inherit, because you can only inherit from a class and implement an interface, but it's pretty much the same thing. Now we have a squiggly line because we don't override the members of unit specific current weather entry. So let's hit Alt Enter, and we want to implement as constructor parameters, and we want to implement all of the fields or properties. And now to make this work, we need to tell the imperial current weather entry what is the name of the temperature property in our normal classic current weather entry. And for imperial, we want to have the temperature to be in Fahrenheit. So the name of the property which we want to get from the database is temp_f. So we can copy temp_f, which stands for temperature in Fahrenheit, and go over to imperial current weather entry. And we want to annotate this property with column info. And the info for this property will be that its name in the database, which we want to get from the table, is temp_f. So let's paste it over here. And we basically want to do this for every single property that we have here. So I am again going to cheat a bit and paste the code in here and then come back and tell you what I did. Alright, so here we go. Condition text. It's still just condition text. It doesn't change because there is no Fahrenheit or Celsius in condition text. The same goes for condition icon. And remember that we are prefixing with condition because the condition is an embedded property here. So everything inside the condition is prefixed with condition and underscore. Then we have, for the wind speed, we have wind in miles per hour. Wind direction doesn't localize well because it's just a direction. And then the precipitation is in inches, feels like it's also in Fahrenheit, and the visibility is in miles. Alright, now let's do the same thing for metric current weather entry. So new class. And here I just pasted everything in, so we have temperature in Celsius and also kilometers per hour and millimeters, and again Celsius and kilometers. Again, you can get the code from the link in the video description. And just one last thing to notice here is that imperial and current weather entries are not entities themselves. They are only classes, and actually imperial current weather entry should be a data class and not a classical class. Alright, so these are not entities, but they are only classes which we can get from our database. The only entity, so entity is something that you actually store in the database, is the normal current weather entry, which is not localized. So in the database, everything will be stored, so also Celsius and Fahrenheit and miles and kilometers, those fields will be stored in the database, and only once we want to get the stuff from the database, we are gonna be using imperial or metric current weather entries. And we need to actually create a way in which we are going to get all of the data from the database. And the way that we are going to do it with Room is through data access objects, otherwise known as simply DAOs. So let's create a new data access object for current weather under the DB package directly. So new Kotlin class, or actually not class, but an interface here, because DAOs are always interfaces when you are using the Room library. And its name will be current weather DAO. Because it's a data access object, we want to annotate it with DAO. And we need to create a set of operations that we can do with the table called current weather, which contains entities of type current weather entry. So we obviously want to be able to add a new current weather entry to the database. So we're going to create a function upsert. And upsert simply stands for update or insert at the same time. So if it's already something there, we are just gonna update it because we actually have only one current weather entry present in the database at any given time, as I explained previously. And if there is no current weather entry yet, we are just going to simply insert it. So we want to upsert weather entry of type current weather entry. And we want to annotate this function with @insert. And the onConflict strategy will be onConflict strategy dot replace. And because it's replace, whenever there is a conflict, which will be pretty much always, because a conflict happens when we have two instances of current weather entry which have the same ID. And basically all of the instances which we have of current weather entry will have the same ID because it's by design, because their IDs are constant and they are all 0. as specified down here. So we are always going to have a conflict. So always when we want to add a new where entry and there is already one present, we're gonna get a conflict and we are going to simply replace the old one with the new current where entry. And we want to have two other functions. One is for getting metric and the other one is for getting imperial weather. So fun get weather metric. This will return live data. We are going to get to that later in this tutorial series. But live data is just a pretty cool data type which you can observe for changes. So whenever the current weather changes in the database, the live data will change too. So we will be notified about this change and we can observe it from other classes which are dealing with the UI or also from the repository. You are just going to learn a lot of things in this tutorial. So let's not bog you down now and we'll get to it later. So we want to return live data and the generic type of this live data will be metric current where entry. And also we want to annotate this function with add query, and this query will select everything from current weather where ID is, and let's interpolate now. So current weather ID, which is the constant from, and let's import it, the constant from this class, current weather entry is right over here. And then let's copy all of this and paste it below. But instead of metric current weather entry, we are going to return imperial current weather entry, and let's also import it. Also change the name from get weather metric to get weather imperial. Awesome, so now we have a way to insert and update and also get weather metric and get weather imperial from our database. We are getting the weather with a query, and the query is an SQLite query where we are selecting everything, which is basically only one thing because there is only one thing present at any given moment. And we are getting it from current weather, which is the name of the table which we have created in the current weather entry entity right over here. And then we want to get only that thing which has an ID of current weather ID. And our current weather entry always has ID of current weather ID. Alright, now the last thing that we want to do in this tutorial is to create a forecast database class under DB. So let's create a new Kotlin class, forecast database. It's gonna be an abstract class and it's going to be annotated with add database. The entities of this database will be an array of currently only one entity, which is current weather entry, and we want to provide it with a class. And also the version of this database is currently 1. Also, forecast database will inherit from room database. Current weather DAO is currently only an interface, and we will let the database class create a real instance of this interface because interfaces don't have any implementation, but classes do. And forecast database will create that implementation in the form of a class for us. And for the forecast database to create an implementation of our current weather DAO, we need to specify it over here as an abstract function, current weather DAO, which will return an instance of current weather DAO. And what's returned from this function will be actually implemented current weather DAO. And then forecast database will also have a companion object. This is because a database needs to be a singleton because it doesn't make sense to have multiple instances of a database at the same time. Also, the first time that you create an instance of this forecast database, we want to build the database with a special method call through room library. So we are going to implement all of that functionality right now. First, we are going to create private var instance, which will be of type forecast database, and it will be nullable and it will be null at first. And we also need to tell that this property is volatile. So all of the threads will have immediate access to this property. This is what this volatile stands for. We also want to have a lock object because we are going to be using threads. So private val lock will be equal to instantiated any. It doesn't really matter what type this lock object is. It's basically just a dummy object to make sure that no two threads are currently doing the same thing. because then it could happen that we have actually two instances at the same time because two threads are working in parallel and it's all messed up, right? Then we are going to create operator fun invoke, just as in the previous tutorial where we created this invoke operator fun in the Epixu Weather API service. So operator fun invoke, this will accept a context. And here we first want to check if instance is not null. And if it is not null, we want to return it straight away. If it is null, we want to call a synchronized block of code. The lock is the lock object that we have just created. And in this synchronized block of code, we want to again check if instance is already initialized. So instance and also null coalescing operator. And if it is already initialized, we again want to return it directly from here. And if it is not, we want to initialize it now in this part of code. And we are going to create another function which will actually initialize our database. It will be a private fun build database. It will also get a context. And here we want to get room class. And on this class, we want to call database builder to get the builder. The context we want to pass in is an application context. So even if this context is a context of a fragment, we are going to get the context of the whole application. And then we also want to pass in the class of our database class. So forecast database class.java. And we also want to specify the database name, which is also stored on the local storage. In our case, the name will be simply forecast.db. And then finally, we want to call build on this builder. And now let's go back to invoke. And if it's not initialized, this instance, we want to initialize it over here. So we want to call build database and pass in the context. And also, whatever is returned from this build database, we want to set the instance to be equal to it. So we want to set instance to be equal to it. Alright, then that's it for this part of the tutorial series in which you are learning how to use all of the best practices and all of the latest libraries to create a forecast application for Android. We didn't create anything tangible in this part because we actually need to also create some kind of a foundation to build off of before we can have something nice and tangible which we can launch on an emulator or on a device. So subscribe to this channel and also hit the bell button not to miss any future parts of this tutorial series where we are actually gonna be creating some tangible stuff which you will be able to see. If this video helped you to understand the Room library and also how to create a database, how to create a data access objects and also entities and all of that stuff, give this video a like and also share it. Leave a comment if you have anything to say, follow me on Instagram, Facebook and Twitter, and see you in the next video.